D is less than 0, it is unstable. This could actually come out as something theory. Then when D is greater than 0, it is statistically indeterminate. So the next step would be to solve our solve our support reactions. The next step. Now probably after we solve our support reaction, we probably chose directions ourselves. So the next thing will now be to use the right direction. I don't know if you actually got what I'm saying. Probably while we were solving, we said, okay, let's the direction for a particular place to be upward. And we know that whenever we are picking upward, it's positive. But when we now solve, at the end of the day, we now got that particular point to be downward, to be negative, sorry. That is the initial sign is what? The downward sign. So we are not going to use the right direction. So the next thing will now be to split columns and beams. Then we now solve the support reactions on it also. Then the last one will be our shear force and bending moment. So these are the steps that we are going to be using for a question. So we have a question here.
What?
This is fixed support level. Fixed support.
Yes, fixed.
So now this is the question. So the first thing we should do now would be so the first thing now will be to our very first step. Yes, 1.6.
You have to rush. You have to do a lot.
This is only MTM that can make 6. So the very first step is to check if it is statistically determinate. So with this formula, that is our D is equal to 3M plus R minus 3J. Now, how many members do we have? This is a member, this is a member, so we have 2 members. So we have 3 into 2 plus the normal reactions we have 3 reactions. Our summation of upward forces, summation of horizontal forces, and our moment. So we have 3 reactions. 3 reactions minus how many joints do we have? 1, 2, 3. I think that's the joint. So let me confirm. Yes. So we have 3 joints. 1, 2, 3. So we have 3 here. So 3 joints into a head. So at the end of the day we have a 0. So it's statistically determinate.
I want to write 2. I don't need.
The normal reactions that we have. Now, to solve the support reaction, we have to draw the free body diagram that will show how all the various forces are acting. So we have this. This is 1.6. So this is a UDL. So we can convert this UDL to a point code. So 1.6 times 15 is going to be what? So this is 24 kilonewton. Then this is 15. This is going to be 7.5. Then we have this here as well. 25. This is 10. Then we have RA HA and MA. Now, this is what I was explaining the other time, that we've chosen directions ourselves. These are our unknowns and we've chosen directions for them. So now the next thing is now to solve. So we are going to solve it the way we normally solve. So we have a summation of Fy, that is upward forces. We are picking upward to the positive. Is equal to what? 0. So that means we have a RA. RA is the only one going on. Then minus 24. 24 is coming down. So it's equal to 0. So our RA is what? 24 kilonewton. The next one is summation of our horizontal forces. We have got HA plus 25 equals what? 0. So our HA is going to be what? Minus 25 kilonewton, which is telling us that the direction we chose for it is what? Wrong. So we are going to have HA to be what? 25 kilonewton in this direction. That was what I was explaining there. So this is what we are going to have here. So now the last one is our moment. We have our summation of moment taking clockwise to the positive equals what? 0. So we are taking moment about A. We are taking moment about A. We are taking moment about A. That means we have what? Minus MA. Because from here, we chose that MA here is what? Anti-clockwise. So that's why I'm having it as a negative. Minus MA plus RA will not act. HA will not act because it's still on that point. 25 is going to act. 25 is coming like this. So it is what? Clockwise. Eh? Why? That's why I'm saying that we chose it. You can choose, you can have to choose it as clockwise. Whatever you are choosing does not actually matter. Because at the end of the day, your answer will be one that will tell you the right direction in which you have to choose for the question. So MA plus 25 is clockwise. We have 25 times 10 plus 24 is clockwise. Just assume that the 24 is here. It's coming towards A here. That's going to give us what? 24 times 7.5 equals 0. This is 7.8. So our MA is going to give us what? So our MA is what? 430 kilonewton meter. Now the fact that we have it as positive from here is showing us that the direction in which we chose is correct. If I had actually chosen this place to be what? Clockwise. If I had chosen it to be clockwise, my answer here is going to be negative. Which is still going to tell me that this direction which I chose was wrong. But let's just turn it back to what initially did. So, yeah, clockwise is negative. Now, we are getting MA as positive. Why? Because the fact that we've chosen that anti-clockwise here, and we've represented it as anti-clockwise with this negative. Our answer, the sign of our answer is just telling us that whether what we chose is right or wrong. It's not showing whether it is clockwise or anti-clockwise. And now let's look at this one now. We chose that this part is positive. But from our answer, we got what? Negative. And that means this negative is just showing that whatever you have chosen as the direction is wrong. It's the opposite direction of it. That's why we have it. That's why we have it. Clockwise direction. So now, we are done with this, we are done with this. The next thing is to use our right direction. We are drawing this three-body diagram again, and we are using our right direction. So we have this. We have 24, 7.5, 7.5. R is 24. H is coming like 25. 25 is going to be 10, 10, 10. So this is what we have. We are done with this now. Now, the next step is step 4. Please hope I'm not too fast. I'm too fast.
Yes.
Sorry, sir. So where did we? Let's go by it again. So the very first step, we have to determine which is what statistically determinate. 3m plus r minus 3j. Members, we have two members. a colon and a beam, two members. Reactions, we have three reactions here: upward, horizontal, and our movement. Those are the reactions. Now the joints, we have three joints. There's a joint here, there's a joint here, and a joint here. So that's why we have to start with zero. And we already stated that when g is equal to 0, it was statistically determined. So we are done with the first step. Now the second step is to solve our support reaction. Now, in solving that, just the way we normally solve our normal beams, if we have ordinary beams, we are going to do our free body diagram from what we have in the first step. And this is a fixed support. As a fixed support, three reactions are occurring there. That's why we have upward, sideways, and movement. That's what we have now. Same thing, our normal three equations of summation of our upward forces is equal to 0. Summation of sideways forces is equal to 0. And summation of movement is equal to 0. Now, me I'm thinking that any force that is going upward is positive. You can decide the way and decide to choose whenever any one force that is going downward is positive. Here also, I'm choosing any force going to the right as positive. You can do otherwise. And the moment I'm also picking clockwise to positive. So now, for the upward forces, you can see what forces are in the y direction, in the vertical direction. We only have RA and 24. Now you can look at it. RA is going up, positive sign. 24 is coming down, again. Minus 24 equals 0. So that's why we have RA is 24. Now the fact that RA came out as negative is telling us that the direction we've chosen for our RA is correct. It's right. That means the RA initially is actually going in the upward direction. Now, the next one is summation of horizontal forces. We are picking the right to be positive. So we have what? HA positive. From the direction we chose. We don't know if the direction we chose is actually correct or wrong. I choose HA is positive. Plus 25 positive equals 0. And at the end of the day, after solving, we got to know that our HA came out as negative. That is to tell us that the direction in which we have chosen for our HA is wrong. So we change it back to the 5 to 8. Now, for the moment also, summation of our moment is equal to what? 0. MA, we chose it as anti-clockwise, so that's why it's working negative here. Plus 25 times 10. This is active on A. So 25 times 10 plus 24 times 7.5. So that it feels confused. That's why I said you can bring this 24 to this point. It's still the same force that is acting here. 24 coming down like this. So moving towards A is clockwise. So you have a 24 times 7.5. Now at the end of the day, we got our MA to be 1 positive. That is the sign is chosen for our MA is right. So that's that part. Now the next part is splitting columns and beams. Now splitting columns and beams, we are splitting this. We have this. Now, at this joint here, now since we have split it, we are not going to take, we are going to consider each of it as one single situation. We are not going to consider this. Now we are picking column first. Now actually that, but that is going to start from beginning, then going to the end. So we are picking this first. Now, at this point, the three forces are going to act. There is a moment here. Three forces are going to act. It's the joint. But we don't know what's happening at this joint. We don't know if it is a fixed support, if it is a roller or anything. We don't know. But now we are if you are just assuming that okay, you don't know it. So let's assume that the three reactions are happening at that point. Now, whatever you get is going to affect you as that okay, the support acting there is a fix or a roller or a support. Now, if we get our MA to be 0, that means we know that this point is either a roller or a support that is there. But if we have our MA to be a value, that means we know that okay, at this point though, there's an fixed support there, but we can't see because it's already there. So we can call this to be MA. We can call this to be RA, and we can call this to be A. Now, this same pattern. Summation Fy upward positive because of 0. So they have what? 24. What are the forces that are acting in the vertical direction? 24 and RAB. Now you can see the RAB is coming down, so you have 24 minus RAB equals 0. So you have 24 equals RAB. So RAB is 24. The fact that we got positive is telling us that the direction from the RAB is correct. The next one, summation of horizontal forces. So we have negative 25 plus 25 plus HAB equals 0. Negative 25 plus 25 equals 0. So now this is telling us that our HAB is equal to 0. That means there is no any horizontal force acting at that point. Now if you look at it, it's actually about balancing. 24 is going up, 24 is coming down, balance. 25 is going to the left, 25 is going to the left. It's already balanced. So obviously no force, no other force is going to act at that point. Because at that point, the horizontal force is already balanced. Now let's do the movement. Summation of movement at a point is equal to 0. I'm coming, sorry, let me just get that. Be about movement about a clockwise is very positive. So now let's go. We have the moment at A is anti-clockwise. That's what? Negative 40. Negative 40. Plus this 25 is acting here. So I don't like this. 25 is still acting on this thing. So we have 25 times 10 in the clockwise direction. Then we have MAB also moving in what? Clockwise direction. Plus what? FAB equals to 0. This is minus 430 plus 250 plus FAB equals 0. Huh? This 25 is not act because we are picking it at point A. Every other thing, and the only thing when you are picking a moment about a point, it's only the moment about that point that will act. Every other reaction will not act. Our 24 and 25 is not going to act because it's at point A. There's no any distance we are multiplying about it. So minus 430 plus 250 equals. We have minus 180 plus FAB equals 0. So our MAB is equal to 180. Which is telling us that
The MAB is coming with
MAB moment you very much. Yes? HAB is 0. There is very doesn't that 0 times 20 is 0. So it doesn't have 0. And RAB is not active because now this RAB is the same thing as telling us that it is active, it is still coming down to this point here. So there's no any distance that is acting about. That's why RAB is that, and HAB itself is what? 0. that we are considering 0. There's no any force counteracting it here. So the HBC is what 0. And the people it's still banned, but you can also see that it is following the pattern. It is what? Clockwise. Do you get it now?
Yes, ma'am.
So we are done with splitting columns and things. So the last one, this is the main aim of the whole calculation, is to solve our Shepard and Bennett.
Okay, thank you. Sir,
Where's the one?
who disappeared?
Where said this was?
Winnie?
So now, in your note, after you are done with this, you can now just like withdraw this and start the Shepard and Bennett calculation. So I don't know, now me I don't have to use method of second for Shepard and Bennett. People actually prefer method of second because it's actually easier. It gives the direct answer. So now the Shepard's calculation. Shepard's at A. Now, this time around we are dealing with a column and a view. Remember when I first learned this, it was very, very confusing when it was Shepard's and A. So now, I will go to this time. For better, to be able to view your Shepard and Bennett very well, you can tilt your column to be a view. You're not changing the direction. You're just making something that is straight. Better. Do you get it now? So now for the column, we're not going to have something like this. This going on. Coming sideways like this. And this is touching. We don't have anything in that part. But we have 5 here. Then we have the movement that is moving in the anti-clockwise direction. Do you understand what I did? I just tilted it. I didn't change any of the direction. I did not change it. I just tilted it so we can easily see our Shepard. Do you get that? So now, this is A and this is B. I always like to label my point load. That's the point load that is given from the question. I always like to label it. So our Shepard will come out very well. Let's label it. But now, from here, you can easily know how our Shepard is going to look like. You don't want to draw a free-body Shepard diagram. Now, this is a datum line. Like a datum line, there's nothing, there's no UDL, there's no video. So now this Shepard is going to look like this. If you want to draw it, it's going to look something like this. I don't know if it's going to be positive or if it's going to be negative, but it's going to become something like this. There is a, what's the name? There's a point load that is dropping it. So it's what? It will come down. There are no any other loads. So it just stay on the datum line. These are our Shepard is going to look like. I should come again. Now, if you look at this.
This is for the column.
No, I'm doing the column. I already said this. For the easy Shepard, tilt it. I'm not doing the beam now. You are that now. I want to draw a Shepard without calculating a Shepard. Actually, you actually need this in MM, this particular is the MM. But MM, you need to draw your Shepard and Bennett moment first. without subtlety. That's how we have. That's the English direction. So we want to draw the shape from this question directly. You don't have any descending point or anything. I don't know that it's going to be positive or it's going to be negative. So I'm just starting from here. This is no UTM, no video. It's just like a lesson line. So that's how I'm having it here. I don't know the point it's going to be. So I'm just having it. I'm stopping here. Let's assume this way is actually here. Now, this is the point code. The point of this was it is dropping it down. It is dropping it down. It's going to come down. Then there are no any other forces acting in the vertical direction. So that's why it's ending here. Do you get? Why did I actually call the attention to this? It's just because of what I said that I always like to label my point code. Do you get? So now let's do for our shear force. Now shear force at A here is what? The upward forces at A. The upward forces. Now, if you see the reason why I said tilt, because if you had actually considered it as a column, your upward forces will be what? 24. Do you get? Do you get what I'm trying to say? So now that I said tilt, so you can actually see properly. So therefore, your F is going to be 25. Now the next thing will be FE prime. These are never solved right. Now the FE prime is just telling that a prime generally happens when you have a point code. As you can see now, after this there is a point code after A. The point code is absorbed. Do you get it? Do you get what I'm trying to say? The point code is that now you cannot just move straight from A to B. It's just like something is going up. Something is going up. Something must have caused this to come down. It's going to come down. Do you get that analogy? If something is going up, it's obviously not stay up or something must have caused it to come down. So we want to know what happened between A and B. What is the situation that occurred between A and B? Now that we have our FE prime, which was also 25 kilonewtons. Now FE itself, now we are considering E. What's happening at E? Considering what's happening at E, you have 25, a point code is coming down. Now you need to also see direction. Sorry. We are taking therefore the opposite was positive. Okay. The point code is coming down. Then so yeah, 25 minus 25, which is 0. Like I said the other time, as C as B here, nothing is happening. No force, no reaction, nothing. So our F is going to give us 0. We are done with the prolonged part. The shape of the prolonged part. Do you get it? Sorry. Do we get this part for the column part of the shape? Now for the bending moment. For the bending moment, we start with NA. At NA, what do we have? We have a moment at MA. As if it was probably a roller or an in support. Our first moment space was 0. This is a free support. Abby. I asked them what's his name. Someone said Stephanie. This is a what support is this? That's in what direction? In the anti-clockwise direction. We have a negative positive. We are done with MA. Now, ME. Remember we already did better this place. ME now, we are taking E as the man in position this time around. So every other thing that we are doing has to affect, that's consent. So we start with this first moment is acting on the brain, on the column, on the brain. It's acting on it. So it's going to still act on it. It doesn't. Therefore, negative force plus this force is going to act on it clockwise. Remember the distance we have here. Clockwise. So you have 25 plus 10 plus there's no any other force acting. So you will stop it. So you have minus 430 plus 25 plus 10. That's what? That's what? Negative 180. So I forgot to add MAB. We forgot to add our MAB. Our MAB is what? 180 clockwise. The one we got here, I didn't add anything. But I didn't just transfer it back. Do we get it? I picked the NAP that we got here. I didn't transfer it when I was tilting back. That's what you are getting. So now, if we do NP prime, why are we doing NP prime? We are doing NP prime because there is a moment at B. You can't just consider NP directly. Why? Because there's a moment at B. You have to first, the moment to first stand that okay. The moment you can stand on the other, you have to treat it specially on my own. So now we have this is going to give us negative 4 plus 25 times 10 plus minus 10. This is 25 times 20 this time, minus 25 times 10. So we are going to have what? Calculate on the ground. This is going to give us minus 180. So you have what? Minus 180. But we know generally our main moment was end at what? 0. That's the main goal. That's why I said treat it on its own. So you are not picking the moment at special case. MB now negative 180. This is moving in what direction? Clockwise. And our clockwise direction is what? Positive. Plus 180. So you have 0. So the share of the measurement for column check. We are left with what? 1 for B. Same thing. The share of there's no need for treating this one. We already have everything. We already treated already. It's here for. So I'm making fast. So the first thing, FB. At B, we have to be out for reaction at B. RBC is what? 24 kilograms. Then now this is what? This is the what? There's a UDL acting there. Now that UDL, that means this UDL here, you don't know whether at this point probably you don't know what's happening. So we can't just go from this B straight to C. This UDL is telling us that something has happened. They've distributed those loads. But we don't know that they distributed equally, so we don't know what happened. We have to find out what's happening in that part. So we have our SC prime, which is going to be 24 minus 24, which is 0. And our SC is now 0 and 0. Because there is no force acting at C. From the question, no force is acting. Do we get it now? So now, that's for our shepherd. Now, for the bending moment for that part, same thing. Our M will give us what? What our M? Remember there's a moment at B here. What we got? MBC. That's what? 180. And it's moving in one direction. Anti-clockwise. That's what negative 180 kilonewton. They will not take the one forward. The one forward. And a point before C. Then just call the gravity. So the one at end is minus 180 plus RBC, that's going to be plus RBC is what? 24 times what? 7.5. And that's what? 24 times 7.5 because this becomes 0. Now for MC it's negative 180 plus 24 times 50 plus minus 24 times 7.5. It's also because of 0. This is also because 0. RBC 24 times 15 up to C. I'm taking a moment about C. 24 times 7.5 up to C. Yeah? Yeah. About this point. Huh? I really consider 24 because 24 is at D. I really consider RBC 24. Yeah? DVL, that's what I really consider DVL. This FC prime is also same to F. DVL. That's exactly. So now let's draw our steppers and measurement diagram. So now our shepherd diagram. Yeah. We'll be using this diagram to draw. Also, this is A. So now what we have shepherd at A is what? 25 positive. So we can just go up like 25 at A. Let me draw the line. So we have this, let's just take this to 25. At E, this is E. So at E is what? The first E prime is what? 25 also. Then E itself is what? 0. Then 0. So if you come like this, go like this, come like this. Join the shepherd first. You can see that it's similar to what we have here. You're basically throwing it the way the question is.
What we do?
This is on the George Shepherd diagram. We have AEB. Remember we already like named that place a point. That point to place. Name it. So we have AEB. What the Shepherd at A? Now what's like you are plotting a graph. Is what I want to know. At A we have what? 25. Let's call it to 25. At E we have what also? How many points do we have for E? 2 points. We are going to plot those 2 points. So at here we have 0. Then at our final distance we have what? B 0. So joining everything together, you have it's coming like this, going like this, then going like this. Remember we fraudulently drew a shear force diagram. You can see it's looking very much alike. So we are done with our chef for today. Now the next thing is to do our what? Bending moment. So the bending moment diagram. Some people actually do it together. So just have to do it together.
I was about asking that.
I don't have to do it. They'll do it together at the same time. Chef and bending, they'll do it together. Me, I don't know how to do it. I've seen it even in past question, even in test. If you enter each other, me, I don't know how to do it. I don't know how to do it. Me, I don't know how to do it. So you may actually see the person that they. You know, in your shackles and bending moments, or even normal one, you can decide yourself and say
Is the values are the same?
your values and even your stature. Now, if I'm going to do all this and something, I'll just put it as a
What's the value there?
and all the values here I was positive. I can draw my shackles diagram. This state, everything here can be positive. But I'm still drawing it below the baseline for this sign. The first sign I'm putting here is trying to say to the letter that okay, everything that this person has here is well. Now let's draw the bending moment diagram for the column. For the column, this is what FA. For FA, you have what? Negative 430 here. For NP, you have what? Negative 180. Let's say this is negative 180. Then for NB, you have two values. The first value is what? Negative 180. And the last value is what? 0. So you do the same joining. You are bringing it down like this. Taking it like this. This is our bending moment diagram. Negative.
Sorry.
Because everything we have there is negative, yeah?
In that stop where enjoying bending moment and shuffle.
I'm doing what?
Everything. So
B24. FC prime 0. FC 0. So you're taking it up like this. I'm doing it like this. Now, why is it? This is also straight. Why is it coming down? It's a medium, uniformly distributed. And I said it. We don't know how it is distributed. It is just showing. This is just saying okay. The load are distributed all around it. Do you get it now? So this is share for that. Yeah? Go where? I said this one doesn't be straight. Mine is not just straight. It's straight. I said it already now. Sorry, let me straight it. Go out there.
Are you straight?
That's still like. That's better. So now we are done with our share force. Bending moment. Now our bending moment at B, you have what? Negative 180. Negative 180. Then at that point, after the video pointer is acting, there's a moment there. You know that this video we converted into a pointer. There's a moment there. That's what I named as what? Empty. Do we get?
yes.
Alright. Zero. Then MCT is what? 0. Now this is already a slope. Then what we're going to have next is going to be a cup. It's going to come like this. Artistic movement. It's going to come like this. It's going to go like this, like this, like this, like this, then go like this. Yeah, so this is what I'm going to have.
That's when it's curved like that. This one has codes.
Are you happy?
That's codes now.
So you come and try it. So you are done with it's called. Sorry, I don't know.
Stop, you can see.
So you are done with one question. Let me read. Now there is one more diagram that they should draw. Axial diagram. I don't know how to draw it. I don't know yet. This class is only 3 diagrams. How many draw axial diagram? What day is it? Over 6 months. Yay! Please do you have a class?
Let's say you have a thing now, or remember, and you have compressive force of 10 kilograms acting on both sides. That means you have 20 kilograms or 10 sides. So when you're drawing your axial force diagram, for this one, it's going to be something like this. Just 10 kilonewton compressed. I can just put minus 10 kilonewton, what that is compression. Then for this other one, same thing. Put 20 kilonewton, 10 side. Or you just put 20 kilonewton, what that is 10 side. That's just all.
So now for a question like
No
this,
compression, no compression. You see that those two 10 are coming inside. This one that we have, the question we have. So we have to introduce it. And that's it up there.
So what did you get your H?
24. 24, but C does not. They are both 0. They change those 0 there.
So for this, you have 24.
No, it's 0.
Okay, if it's 0, then you have nothing here.
Okay. What about for the column?
For this one, what do you have here?
24
24
and
and
24.
That means you're going to have compression. 24. Is this negative?
It's compression.
They are both it's compression, so minus 24. Okay.
Just like that. Just like that.
So cut it.